In the realm of celestial bodies, asteroids represent some of the most intriguing yet potentially dangerous objects in our solar system. Among them, the asteroid Apophis, discovered in 2004, has garnered significant attention and concern due to its size, trajectory, and the implications of a potential impact on Earth. Initially heralded as a potential killer asteroid, Apophis serves as a reminder of the ongoing need for vigilance in monitoring near-Earth objects (NEOs) and understanding the dynamics of their orbits. This article delves into the history of Apophis, the scientific evaluations of its trajectory, the potential consequences of a collision, and the ongoing efforts to study and mitigate the risks associated with such asteroids. The story of Apophis began on June 19, 2004, when astronomers Roy Tucker, David J. Tholen, and Fabrizio Bernardi identified a previously unknown asteroid orbiting in space. Dubbed Apophis, named after the ancient Egyptian god of chaos and darkness, this celestial body measures approximately 350 meters in diameter. The name alone conjured images of doom, and the initial assessments by NASA and other astronomical institutions confirmed the public's fears. In December 2004, estimates placed the asteroid's impact probability at about 2.7% during its close approaches to Earth, specifically on April 13, 2029, which happens to be a Friday the 13th, a date that further fueled media hysteria. This impact probability represented one of the highest values on the Torino scale, a system used to categorize the risk level of NEOs. In the wake of this announcement, the media response was overwhelming. Headlines blared warnings of impending disaster, and discussions about asteroid impacts permeated popular culture. The potential for a catastrophic collision, however unlikely, captured the imagination of many and served as a reminder of the vulnerabilities our planet faces in the vast expanse of the universe. As the scientific community delved deeper into the study of Apophis, initial fears began to subside. Detailed follow-up observations and analyses revealed that while the asteroid's trajectory was indeed precarious, the probability of a collision with Earth in 2029 was much lower than initially thought. By 2021, NASA experts concluded that Apophis would pass safely at a distance of approximately 32,000 kilometers from Earth, well below the threshold of geostationary satellites. This assessment was bolstered by ongoing monitoring and refined calculations, which took into account the gravitational influences of other celestial bodies and the effects of solar radiation pressure on the asteroid's path. One critical factor contributing to the asteroid's changing trajectory is the phenomenon known as the Yarkovsky effect, which occurs when the sunlight heats an asteroid's surface and causes it to emit thermal radiation. This radiation can impart a small but significant amount of force on the asteroid, gradually shifting its orbit over time. For Apophis, scientists have determined that this effect could be causing a displacement of about 170 meters per year. While this shift does not currently pose a threat of an impact in 2029, it raises questions about the asteroid's future trajectories and the potential for collisions in subsequent approaches, specifically in 2036 and 2068. Despite the decreasing likelihood of an imminent impact, the hypothetical consequences of an Apophis collision with Earth remain a subject of concern. Researchers have estimated that if Apophis were to strike the planet, the energy released would be equivalent to approximately 900 million tons of TNT. This explosive force far exceeds that of the atomic bomb dropped on Hiroshima, which had an energy yield of about 15,000 tons of TNT. The impact crater created by Apophis would be several kilometers in diameter, devastating an area comparable to Central Europe. The immediate aftermath of such a collision would involve widespread destruction, with the potential to annihilate entire cities and disrupt ecosystems. If the asteroid were to land in the ocean, the resulting tsunami could reach heights exceeding 100 meters, inundating coastal areas and causing catastrophic loss of life and property. The specifics of the impact would greatly depend on the location of the strike. An oceanic impact could result in significant tsunamis, while a land impact would devastate the immediate vicinity and result in extensive fires and secondary effects that could lead to a nuclear winter scenario, blocking sunlight and disrupting global weather patterns. However, scientists emphasize that the scale of devastation would be significantly less than that caused by the asteroid that led to the extinction of the dinosaurs 66 million years ago, primarily due to the smaller size of Apophis. As researchers continue to monitor Apophis, they are also investigating potential methods for deflecting asteroids that may pose a threat to Earth. The successful demonstration of the DART, Double Asteroid Redirection Test, mission in 2022 showcased the feasibility of changing an asteroid's trajectory using a kinetic impactor, essentially colliding a spacecraft with the asteroid to alter its path. This mission involved the spacecraft deliberately crashing into the smaller moonlet of the binary asteroid Didymos, effectively testing our ability to redirect a celestial object. If a similar scenario were to arise with Apophis, researchers have determined that even a small collision with a significantly smaller asteroid could transfer enough momentum to redirect Apophis's orbit. Weird's analyses indicated that an impact with an object merely 60 centimeters in diameter could sufficiently shift Apophis's trajectory by approximately 200 kilometers, allowing it to enter a gravitational keyhole that would redirect it toward Earth in a future approach. While the chances of such a collision occurring are low, estimated at around 1 in a million, the complexity of asteroid dynamics underscores the importance of continual monitoring and analysis. Astronomers have recognized that even minor shifts in trajectory due to gravitational influences or collisions could have profound consequences. Therefore, even as we maintain vigilance over Apophis, scientists are working on developing advanced tracking systems and models to predict and mitigate potential threats from NEOs more effectively. Despite the reassurances provided by current calculations, the need for continued monitoring of Apophis and other near-Earth asteroids is paramount. From February 2027 onward, Apophis will re-enter the observable sky as it moves away from the Sun. At this point, astronomers will be able to track its trajectory more accurately and assess any changes that may have occurred during its time out of view. Observations of Apophis's trajectory will provide valuable data, allowing scientists to determine if any adjustments to its orbit have taken place. Scientists have proposed the development of small satellites to accompany Apophis during its approach, enabling more precise measurements and monitoring of the asteroid's surface and trajectory. These efforts would not only enhance our understanding of Apophis but also contribute to our knowledge of the composition and behavior of NEOs in general. Moreover, studying Apophis presents a unique opportunity for scientific inquiry, as close encounters with asteroids of this size are rare, occurring approximately every 100 years. The passage of Apophis will enable researchers to investigate its surface properties, structure, and potential resources, as well as improve our understanding of the dynamics of asteroid orbits. Insights gained from Apophis could also inform future planetary defense strategies and asteroid mining efforts. In the realm of celestial bodies, asteroids represent some of the most intriguing yet potentially dangerous objects in our solar system. Among them, the asteroid Apophis, discovered in 2004, has garnered significant attention and concern due to its size, trajectory, and the implications of a potential impact on Earth. Initially heralded as a potential killer asteroid, Apophis serves as a reminder of the ongoing need for vigilance in monitoring near-Earth objects, NEOs, and understanding the dynamics of their orbits. This article delves into the history of Apophis, the scientific evaluations of its trajectory, the potential consequences of a collision, and the ongoing efforts to study and mitigate the risks associated with such asteroids. While the threat of Apophis colliding with Earth remains a distant concern, the ongoing research and monitoring of this asteroid underscore the importance of preparedness in the face of potential cosmic dangers. The calculations and models developed by scientists offer reassurance that, at least for now, the asteroid poses minimal risk. However, the unpredictable nature of celestial mechanics and the possibility of unforeseen events necessitate continued vigilance and proactive measures. The study of Apophis not only highlights the importance of understanding the dynamics of near-Earth objects but also emphasizes the broader implications for planetary defense. As we advance our capabilities to detect, track, and potentially redirect asteroids, we move closer to safeguarding our planet from potential impacts. The passage of Apophis will serve as both a cautionary tale and a unique opportunity for scientific discovery, reinforcing the idea that in our vast universe, preparation and understanding are our best defenses against the unknown. As we look to the future, the collaboration between astronomers, space agencies, and researchers will be crucial in ensuring that we remain alert to the threats posed by asteroids and continue to enhance our ability to protect our planet from potential disasters. Thanks for joining us on this cosmic journey. Don't forget to hit that subscribe button to stay updated on all things space. Until next time, keep looking up and exploring the wonders of the universe with Space Lab.